from my networking travels, they are the smartest people in the lands of cryptography, not just in the UK, but globally. So they're helping me with my ideas. So I thought there'd be three parts to the talk tonight. A bit of education, followed by a demo, go into the IoT health, followed by a demo, and then go into wearables and do a demo. There's a lot of mystique about this blockchain thing, so I think just by seeing it multiple times, hopefully some of the terminology and what it means more. So let's start with some education. Let's go back just over 400 years ago. There was a prevailing belief that the world was flat. And the early scientists, as we call them now, through the logic and reasoning and measurement, started to fathom out that this might not be the case. However, it was a risky business. So there was a risk of death if you asserted that the world was round back in 1600. And this is the surname of a famous scientist. Can anybody decipher it? It's an example of what we call a Caesar cipher. No? Nobody's been to my talk before? I see a few people with keyboards. So if you were to take the letter N and go one to the left, you get a B. And if you take a T, you get an R, and you follow that, you get Bruno. Giovanni Bruno, burned at the stake in downtown Rome in 1600 for a certain revolution. I tell this story for two reasons. One, to show that cryptography has been part of society's governance for a long time, and also to make the point that it does have a bedrock in the encryption, in Bitcoin's case, SHA-256. So I think, I know that other speakers are going to go into depth what these mean, but I just thought we'd set the scene. So a hash is just saying you take a big string, say of like 1,000 words, and give yourself 120-bit string of jumbled up numbers. And if you were just to change one little dot in that 1,000 words, the hash would look completely different. And this is what a Bitcoin transaction is. Transactions are gathered into blocks. The blocks come to be because of a process called mining. So I should have asked, how many people have got Bitcoin in their wallet right now? Ether coins? No. Safe coins? No. Color coins? No. Cool. So how did these coins come to be? So if you were looking for some gold, what would you do? You'd have to go to some rock and get some dynamite, drills, and you blast it. You gather up the ore, and then you put some heat, some more energy, and then you distill the gold, and you might make it into a little nugget. And at some point in time, that was worth $1,000 or a few $100. So Bitcoin, we don't mine for this ore of gold. We mine for big, large prime numbers. And so Satoshi Nakamoto just created this abstract mathematical game called Hashcash ×2, which just says every 10 minutes there's this hard problem to solve. And the hard problem you've got to solve is just fire numbers at it at random. And it will tell you if you've got the right number for this particular puzzle. And right now I think there's 30,000 computers, many supercomputers worth of energy going in to find these every 10 minutes. So this gave us this mechanism to join blocks, and this is called proof of work. Right now, I was talking to someone earlier, said I could give you some money on my credit card and then run, and eventually the banking system would catch up with me. But if I was to give you 10 Bitcoins, we could have cryptographic proof that right here and now, at a peer-to-peer transaction, I have those coins to give to you. And if I didn't have 10, the transaction would go. And tonight, now that we've got the basis of a simple monetary contract, projects like Ethereum and Rootstock have now given us this notion of a smart contract, which is just a computer program running on this blockchain infrastructure. So just what does it give you, all this technical stuff? The mutability, you can't go back and easily change the past. Some would say now there's such a level of difficulty in Bitcoin, you could maybe do it for a few days, but it was so economically and computationally intensive that well, no one's succeeded to date. There's no single point of failure. There's these 30,000 nodes across and the point I try to sort of just bring it all together, it's not just cryptography, it's not just software rules, it's human psychology, it's game theory, it's this new something, and no one actually has got a scientific definition of what it is, but what we do have is a problem solved, which was how do you have consensus on a distributed network. That was a fundamental problem in computer science, and now Satoshi has solved that, but we don't understand all the bits that make up the logic to do that. So time for a demo. So I thought we'd do two things tonight. I thought we'd build a transnational bank and then a transnational health service. So we're going to start with the bank. Any guess how many lines of code it takes to build a bank?
20.
Yes. Is that plain? Yeah. That's probably a bit small. This is an example of a Solidity contract, version 4. We're up to 4.2 today. And if you're a computer programmer, you'll see it just looks like an object. And if you're familiar with JavaScript. So all we're saying that this meta coin we're creating needs some seed capital. Decided to give it 300,000. For the basic setup, we had the banker and we have a simple two-person peer-to-peer network. And what we're going to do is create the contract. So the banker, which is the top one, created the contract. So here we have the smart contract initiated, and this node here is going to mine for these cryptographic numbers to verify that this transaction is now part of the blockchain. And here we see, yes, it's mined and ready. So we now have our coin with this 30,000 balance, or 300,000, in existence. So the next thing we need to do is send the money from the base capital to the customer. So the customer is this person in the bottom right. So I think we're going to send them, we're just checking that, yeah. I think we'll just check that the customer has no balance because there's been no transactions, just to verify our contract's truthful, yeah. So now we have to put in our public key to the customer. I should have said I had planned to do this live tonight, but I wiped my hard disk drive, but luckily I recorded this 5 minutes before.
Sucky wasn't a Bitcoin wallet.
Well, my Bitcoin wallet is on there, but I do have a backup for that.
Okay.
So here again we have a transaction. So what we're going to do here is check the balance, because the 300,000 should be lower and the customer's balance should be 201. And we'll notice the numbers never changed. Does that mean why that was a bug in my contract? It wasn't accepted because it required a function to be certified by the blockchain. So anytime you change state in Ethereum, that costs you something. It's called gas. So now that it's been accepted into the blockchain, now the money has been cryptographically certified, and this will go down. Now this goes on to create a central bank showing quantitative easing, but for time. Okay, so we've done our bank. What problem are we trying to solve with IoT? So Bitcoin had solved this double spend problem. So does IoT have a double spend problem? To some degree, but I don't think it's the heart of the issue. Ethereum builds on this proof of work, the concept of gas, to keep these contracts. So if you have thousands of computers and you've got a big compute job, and they're all going for free, you would just use them, right? So there's a cost, and that's part of their economic incentive. our friends across at True want to monetize our hard disk that drives it home, and they call it proof of resource. And I think we've got a lot harder job when we combine IoT sensors into health or wellness or whatever context. Why? Because just because we can account for these things immutably. It says nothing about the honesty or the trustworthiness of the content that's actually been saved. So you could have garbage content certified immutable. It's still garbage content. So I think our job in IoT and